Hi, Algebra 1. Sorry I'm not there today, but we're going to learn lessons no matter what. So here we go. We're going to play some absolute values with inequalities. So we've already covered about absolute values for the equal sign, but now we're going to have to do this for inequalities. So let's just break down some of the basic terms that we need to know before we go forward. And or. We use them a lot, but in a mathematical sense, it's a very specific meaning for what and is and what or is. Let's use an example. If I had two friends, Mr. Kang and Miss Kennedy, and I said, hey, I'm going to make pizza for Mr. Kang and Miss Kennedy, how many pieces do I have to make? Given that I'm going to make it for, and I'm making for both of them, that would mean I need two pizzas. One for each. If I had said I'm going to make a pizza for Mr. Kennedy or Mr. Kang or Miss Kennedy, then how many pizzas do I need? If I said the or statement, then I only need one. In this case, I don't really care who I give it to. I don't care who gets it, but I just have to make sure one of them gets it. So it's an or statement. You can think of it as mathematically and needs everything to be true, whereas or just needs to be at least one thing true. If you remember how the world of Venn diagrams work, it's very much the same concept, where if I was going to be, let's say, negative, wrong setting, let's go with my highlighter. If I said negative and even, those are numbers that are going to be negative and even. Had I said negative or even, well, these are negative, these are even, so those also work. These are a little bit of both, so that also works. And needs everything to be specifically true, or just means one of them to be true. At least one thing is true. So let's try some things out. Let's do one at a time. I have x is less than or equal to -5. So if I have my 0 here, go 1, 2, 3, 4, 5, -5. And I can go 1. I'm going to say that this is a closed dot because there's less than or equal to. And we're going to go in this direction. Yeah. And I also have x. On this one, I have x is greater than 7. 1, 2, 3, 4, 5, 6, 7. 7 is here. This is a strictly greater than, so it's an open dot, and it's going to be greater, so it's anything over here. Any number that's going to be less than or equal to 5 over on this side will make this true because it's an or statement. Anything greater than 7 is going to make this part true, which makes this whole thing true. The fact that I have an or statement, it can work either way. For number 2, let's look at number 2. I have -4. Well, this is 0. 1, 2, 3, 4. -4. And x is greater than -4. That's an open dot going in this direction. And x is less than or equal to 0. So closed dot and going this way. But the only part that actually is valid is this space in between. Because anything greater than 0 might make this true, but it will not make this true. And since I did an and statement, it needs to be both true. Needs both to be true. All right, take a moment. I'm going to let you graph this one, 3 and 4. I'm assuming you can pause this at any time, so pause away. But as it goes, I'm just going to specify it as this is an AND statement, so it needs to be making both sides happy. If I were to have this at 0, this is -2, -4, -6, -8, then this one should be x is greater than, let's go in this direction, and -2, x is less than -2 going this way. So it's only the space in between here. As for 4, I have -1 and 0. X is, it's inclusive, so less than or equal to -1, so this direction, and less than go to 0. Given that it's an OR, all of these numbers count, even the numbers in between 0 and -1, because it makes one of them happy. Slightly weird cases. So these are slightly weird, but let's just do them out. So first one up, -7, 1. If this is 0, 1, 2, 3, 4, 5, 6, 7, -7 over here, this is going to be greater than, x is greater than or equal to, so we're going this direction. Yes, it's greater than. Over here, we're at 2, and I have x is less than 2. What makes this a slightly weird case and is amusing is this goes on forever, and this one goes on forever. Given that's an OR statement, that means as long as one of them is satisfied. So any negative number is going to work. Any positive number is going to work. Any 0 is going to work. This going in both directions as an OR statement, this means it's going to be all real numbers. On the other slightly weird case, let's try this one out. I have -5. So if this is 0, 1, 2, 3, 4, 5, -5, it's going to be an open dot because it's strictly less than -5. So it's going to be this direction. This is an AND statement. So I have a 3, 1, 2, 3, and this is x is greater, strictly greater. They're going in different directions. There's no overlap. And this is specifically an AND statement. So is there any number that would make both of these happy? Any number that's over here is going to make this one happy, but it makes this one sad. Any number over here is going to make this one happy, but this one's sad. There's no number that I can fit to get both of them happy. And that's the key, that we can't do this one. This one has, you guessed it, no solution. I'm going to let you do the next two, but I'll just show it. I'll do it with the x is less than x is greater than or equal to 4, and x is less than or equal to 4. So if I have this as 0, 1, 2, 3, 4, right here, it's going to be a closed dot going in this direction, and then for the blue, I'll just do it in blue, it'll be a closed dot going in this direction. What is the answer for this? Given that it's an AND statement, it needs to be a number that satisfies both. And quite frankly, it's only satisfied right there. Only at 4. Because anything bigger, it will make one side happy, but not the other side. So only at 4 is this true. The answer for this is strictly just 4. Try this unique case out. I have x is greater than 8. Let's just count by 2. 2, 4, 6, 8. Open dot, and it goes greater than. And x is less than 8. So open dot this way. Any overlap? Here's the tricky question. Is there any overlap? Yeah, they overlap at 8, but truthfully, can I even be at 8? That's an open dot. Open dot means that it's a hole. I'm going to fall in there, and I can't exist there. So there's no possible solution given that I can't even live at 8. So again, no solution. All right, let's play some real algebra. Let's do this. Let's clean up some of these numbers. I have negative 2x plus 3 is greater than or equal to 7. Let's clean this one up. Let's isolate my variables. So I can just have minus 3, negative 2x is greater than equal to 4. I'm going to divide this by negative 2, divide by negative 2. What happens when I divide it by a negative number? Very important alligator swap. So I'm going to get x is less than or equal to negative 2. Keep in mind that I swap the signs. Whenever I multiply or divide by a negative number, I have to swap the signs. I still have an and statement. So let's do the other side. Negative 4x is less than or equal to negative 3x minus 1. I can just bring over the x's actually. Plus 3x plus 3x. I'm going to get negative x is less than or equal to negative 1. Divide by negative 1, divide by negative 1. I'm doing a lot of dividing by negatives so that you can practice your switching signs. Divide by negative 1, divide by negative 1 on both sides. You're going to have to switch that sign. Let's do it. X is greater than or equal to 1. Negative 1 divided by negative 1 is 1. So this is so far my answer. Let's see what actually comes from it. On the blue side, I have negative 2 right here. This is an inclusive circle. This is less than. So we're going to go less than, you go through here, and this is a 1, and this is, I'll use it in red so I can keep consistent, 1, this is closed up, and it's going to be greater than this direction. Is given that this is an and is there any number that satisfies both of these? There's no number makes both happy. One might be happy, but the other one's going to be sad. So, in doing so, there is no solution. Okay, good. For number 10, let's go. This is our distribution. We'll do a distribution game. When you distribute this, I'm going to get 3x plus 3 is less than 9, minus 3, minus 3. I have 3x is less than 6. Divide by 3, divide by 3, x is less than 2. Okay, got 1. And on the other side, this is simplified. I'm just going to divide by negative 2, divide by negative 2. Swap the signs, and I get negative 4, and I get x. So here are my final answers. On the blue side, I have 2. It's going to be an open dot, and it's less than, so it goes in this direction. On the red side, I have 4, negative 4. Open dot going this direction. Given that it's an and, it's going to be the space in between. there's an overlap. That's the space in between. Mm-hmm. Cool. Can you work on this one as a table? I'm gonna let you figure this one out together. Check with each other for your answers. Okay, this is where we're moving into the harder part. We cover the basics. This is the part where there's a key vocabulary term about this, and for lack of better advice, I'm going to teach you it with a very useful pneumatic. Greater has an or in it, and less than has an and in it. If you set up your equation and you have your absolute values on the left side, whatever the statement of saying greater or less than will tell you if it's going to be an and or an or. So here's an example. This right here, given that I set up my absolute values on the left side, this is going to be an less than. Less than. Key emphasis on the and. So just like we said about prison breaking your absolute values, you're going to have to go a positive and a negative version. X is less than or equal to 3, and x is less than or equal to -3. Same rule applies about signs and switching your signs. Now that I'm adding a negative sign onto this one, since I have a negative side on the negative side, the sign switches. So this is the positive, and this is the negative version. Given that this is less than, this is an and. When I graph this out, I can go from 3 inclusive, and it's going to go less than 3, -3, and it's going to include, it's going to go this direction. Given that's an and, it's only the space in between. Yes, hopefully that makes enough sense. Given, all right, so trying slightly harder, upgrade a little bit. This statement, given the absolute, it's all by itself, and I have negative, I have the absolute value of x minus 1 is greater than 5. The key emphasis is greater. Then when I do my split, the positive side, this is the negative side, and I'm going to have x minus 1 is greater than 5. X minus 1 is less than -5. Make sure you swap out the signs. Okay? This is going to give you plus 1, plus 1. I have x is greater than 6 over here. Given that this is a greater, it's going to be or, and I have plus 1, plus 1. X is less than -4. Let's graph this out when I'm at the 4, at the 6. 1, 2, 3, 4, 5, 6. 6 is here, opened up. It is greater. And over here it is -4. And it is less than a 6. Either this number, anything over on this side, or anything on this side, it will satisfy one of them, and thus it will make this statement true. We can test it out. Let's plug in. Let's plug in 7. If I plug in 7, let's see what I get. 7 minus 1, absolute value, is greater than 5. I'm going to get 6, absolute value of 6, is still 6, and that is greater than 5. Yay, that is a true statement. Let's choose negative 6 over here. Plug that in. So I have negative 6 minus 1 equals, that's going to be negative 7. Absolute value of negative 7 is 7. 7 is greater than 5. That is also true. These are true statements. Either or is going to work. So we're good. Everything on this side works. Everything on this side works. Table do. I'm going to leave this to you to do yourselves. Let's just read this out. This is a great or. Great or. Emphasize great or. It's a pneumatic that really is the best way I can teach it, to be totally honest. So when I split this, I'm going to have negative x minus 2 is less than or equal to 6. This is the positive side. And on the negative side, I have negative x plus 2. Oops, sorry, there's a plus 2 here. And that's going to switch the sign and get a negative 6. That's plus 2. Oh, not plus 2, I want a minus 2. Minus 2, minus 2. Negative x is greater or equal to 4. Divide by negative 1. Divide by negative 1. I get x is less than or equal to negative 4. On this one, given that's an or statement, I'm going to have minus 2, negative x less than equal to negative 8, divide by negative 1, divide by negative 1, and I get x is greater than, switch the signs, 8. Let's set this at 1, 2, 3, 4 here. And this would be 8 here. This one inclusive, and it's going to be less than. And this is going to be inclusive. X is greater than 8. Given that it's an or statement, anything on this side, anything on this side counts, anything on this side counts. I'm going to leave this one to you to work as your table. Remember, you cannot distribute. Do not distribute over absolutes. You're going to have to multiply by its inverse. Good luck. Yep, that is all the assignments I had for you for this note. I think you can do it. Thank you. You do have homework for this. I also posted the study guide. It's not due until the test, but if you're just so fast and you do everything, hey, you got something to work on. Check with your classmates. Have a good one.